Hey Algebra 2, this is video 1 of 2, and in this series we're going to learn how do you transform a parent function, and what in the world does transform even mean? So the last section we did parent functions. It was the simplest form of a graph, and we just had like a basic absolute value that went to the origin. Here we're going to take that same shape and we are going to shift it left, right, up, down. This is what A does. We're going to save that for the next section. So, what does H do? H shows if something has moved right or if it has moved to the left. So this is parentheses, but it could be any of the grouping symbols. It could have an exponent of 2 for the quadratic, an exponent of 3 for the cubic. It could have the radical around it for the square root, or it could have the bars for the absolute value. So this is just representing any of the general grouping symbols that you see. So let's say that we want to show a function moving 2 units to the right. If I use the absolute value as my generic symbol, it would look like this. Y equals the absolute value of x minus 2. So this is what H does. And anything traveling with H associates with x, and your x always lies to you. So if you were going to the right, you might think that that was a plus 2 because that goes to the right on the number line. But if you'll notice here, your formula uses x minus h. And so if we're going to go to the right 2, when we just plug a 2 in right there, it looks like x minus 2. So you have to remember that your x always lies, or it does the opposite. So that means it's going to go 2 to the right. Let's say it's going to go 7 to the left. So you might think that that was a minus 7, but going to the left is a minus 7. So this negative 7 paired up with that negative from the formula, a negative negative turns into a plus. And so if we use the absolute value, left 7 becomes x plus 7. K is associated with moving up or down. And it's just a plus or minus number at the end of the equation. So if we wanted to go up 3 units, it might look like this. Y equals the absolute value of x plus 3. And if we wanted to go down 8 units, so if you go down, that would be a negative 8 on the number line, so it would look like this. Y equals the absolute value of x minus 8. H and K pair up and they work together, and they tell you where your vertex is located. The vertex is always located at H comma K. All right, so let's apply this and do an absolute value. So the absolute value, hopefully you remember from the parent functions that that is going to give you a V shape. So we know that if you get a V, you're doing it correctly. I'm going to sketch on here what the parent function looks like. So there is your basic absolute value parent. So I don't have anything here with the x. And so that basically means that h is 0. There was no left-right movement. But we have a plus 5 off at the end. That is your k value. So k equals 5. So I can tell from right here looking at it that my vertex is located at 0, 5. And if I were to describe my transformations this function went up 5 units. When your graph goes up 5, it's as if you take every single point and they all shift up 5. So my vertex that was at 0, 0, it shifts and it's now at 0, 5. This point that was at 1, 1, it shifts up and now it's at 1, 6. Its mirror point back here at negative 1, 5, or negative 1, 1, it shifts up and now it's at negative 1, 6. So this is what my new actual graph will look like. I'm going to teach you how to make a table of values to plot these blue points. I always start with the vertex in the middle. So there's my vertex. And then since I know that there is symmetry, I always choose 2 smaller points and 2 bigger. So, and it's all about whatever this starting x value is. So from 0, if I were going to go smaller, that would be negative 1, negative 2. And if it were going to go bigger, that would be positive 1, positive 2. All right, so let's plug them in and verify that I get these blue points. So if x is negative 2, I have the absolute value of negative 2 plus 5. And there it goes, it's on the page. The absolute value of negative 2 is 2, and 2 plus 5 equals 7. So my y value is 7. I'm going to plug negative 1 in for x. So the absolute value of negative 1 plus 5. The absolute value of negative 1 is 1. 1 and 5 is 6. I don't need to do the vertex. And then I'm going to go to positive 1. The absolute value of positive 1 plus 5. The absolute value of 1 is 1. 1 and 5 is 6. And then I'm going to plug 2 in. So I have the absolute value of 2 plus 5. The absolute value of 2 is 2, and 2 and 5 is 7. So remember an absolute value, this v has symmetry. I thoroughly expected these two y values to be the same and these two y values to be the same because there is symmetry on it. Since I have symmetry, on future ones, I'm probably only going to do the 2 bigger ones and then just reflect those y values across. All right, so plot these points. Negative 2, 7. All right, that's right there. Negative 1, 6. Yep, that's the one that I moved. My vertex is at 0, 5. My next point is at 1, 6. All right, so that matched the one that I just shifted up 5 units. And 2, 7. It matched. So now I need to go on and do the domain. Domain, you have to remember, are what x values are you allowed to plug in your function. I can plug anything that I want in. So my domain goes negative infinity to infinity. Your range is the y values that you get out. So learn to read your graph from the bottom up. So the smallest y value you come to is 5, and then these are going up to positive infinity. So my range is going to be 5 to infinity. The x-intercept is where does the graph cross the x-axis, and we're talking about my blue actual one. And it does not, so I would write none. And then there's your y-axis, and the y-intercept is where does your graph cross the y-axis, and it crosses right here at 0, 5. The y-intercept, you need to be in the habit of writing it as an ordered pair, not just a number. So that is how you transform an absolute value. we're going to do quadratics on the same video. So that x minus 1 there, that tells me that my h is 1, and the 4 is your k value. So these two work together, and that tells me that I have a vertex at 1, 4. So you have to remember that your x always lies to you. So this minus 1 means that your graph went to the right 1 unit. And the plus 4 tells you how much it goes up or down, and it's positive, so therefore it went up 4 units. All right, the quadratic is a U shape. It's a parabola. So if I were to sketch, it goes there, 1, 1, and 2, 4. So here is my parent. And so this time, I'm going to pick up the parent, and I'm going to shift every point right 1 and up 4. So if you start at your vertex right here, you go right 1 and up 4, so that's where my new vertex is. This point, I'm going to go right 1 and up 4, so now you are at 0, 5. This point that was at 1, 1, when I go right 1 and up 4, it looks like this. So this blue is my actual. Let's make a table of values and verify that we get the points, the same points. So you take your vertex, and I always start it in the middle of my table of values. And then I use 2 smaller numbers and 2 bigger numbers. So think of this as just a number line. So when I go bigger, that means I'm going to use 2 and 3. And when I go smaller, that means I'm going to use 0 and -1. Just like the absolute value graph, this is going to have symmetry to it. So this y value will match that one, and that y value will match that one. But just to double check, I'm going to plug them all in today. When x is -1, I'm plugging it right here in for x. I get -1 minus 1 squared plus 4. Still on the graph. Okay. -1 minus 1 is -2 squared. -2 squared is 4. And 4 and 4 is 8. Do I have a point at -1, 8? Why, yes, yes I do. It's right there. Now I'm going to plug 0 in. 0 minus 1 squared plus 4. 0 minus 1 is -1. -1 squared is 1. And 1 and 4 adds up to 5. I'm going to skip down to the 2. So I have 2 minus 1 squared plus 4. 2 minus 1 is 1 squared plus 4. 1 squared is 1. And 1 and 4 adds up to 5. So whatever this answer is, that's your y value that goes right there. And then I'm going to plug 3 in. I have 3 minus 1 squared plus 4. 3 minus 1 is 2. 2 squared is 4. And 4 and 4 adds up to 8. So because these two are always the same as these two, that is why I generally only do the bigger numbers. Your domain, any x is okay. It goes -infinity to infinity. Your range is your y value, so you come up and 4 is the smallest point that you come to, and it goes up to infinity. Your x-intercept, it does not cross the x-axis, and your y-intercept is right there at 0, 5. Look at the next video, and I'm going to cover cubics and square roots.